Hello and welcome back to our next maths lesson. And we're going to continue to build on what we've done before, which is ordering fractions. But this time we're going to include fractions that are greater than 1. I'm going to tell you a secret now. It follows the same rules, surprisingly. But let's go through everything and see what we can do. So, here's 4 questions. See what you think. Have a look. Have a go. Pause now and give it a shot for me. Okay, so let's have a look. The first one is an equivalent fraction. So it depends on what we've done to 9 to get to 27. And what have we done? To go from 9 to 27, we've times by 3. So we must also times the top by 3 as it is an equivalent fraction. And that's why we get to 6. Same comes here. What we're doing is looking at which one of these two is larger. Well, we need to make sure that we are comparing the same thing, either same denominator or same numerator. Let's have a look, see if we can't make the same denominator. So to get from 9 to 18, I'm going to have to times by 2. Do the same to the top, times by 2, and I get 14. They're actually the same. They're equivalent. Then we've got a fraction over 7 that is larger than 1. Well, this is easier than it seems. If we know that 7 sevenths equal 1, we know that our improper fractions, any number above 7 is more than 1. So this number here could be any number above 7, literally any number above 7. And that would mean that this is bigger because we've got more than 1, which is 7 sevenths. Then we're looking at comparing these two. Now, it's not easy to compare to get the same denominator in this case. So we're going to aim for the same numerator. In order to get this 1 to be the same as that, I need to times it by 2. So I need to times the bottom by 2. So I need to times the bottom by 2 as well. And that's 2/16. Now remember, the smaller the number of pieces, the bigger they are. So this one would be bigger because the piece size is smaller. I know it sounds odd, but remember, denominators, when you're comparing them, the smaller the denominator, the bigger the piece. And if we've got the same number of pieces, then we want the bigger pieces. Have a look at this one. So write and compare these fractions. We've got 11 sevenths and 9 sevenths. Pause now and have a go. I hope that didn't take long, because I hope everyone can tell me that because our denominators are the same, all we have to do is compare the numerators, and you should all be able to tell me that 11 is greater than 9. Here's 11, here's 9. Very much so, we have more here. But we know that because all we're doing is comparing numbers and comparing them in the right order, because that's what happens when our numerators are the same. Told you, same rules. Exactly the same rules continue to apply. Have a think about this one. What could we do to help us? We could draw it out, and that will tell us. What other thing could we have done rather than draw it out? Yes, we could have used the same rule and get the same denominator. We could times 5 by 2 to get 10. Then we have to times the top by 2 and we get 14. Then we know we have the same denominator, and then we just compare our numerators, and 14 is bigger than 13 because our denominators are the same. I hope that part at least is okay. It's exactly how we talked about doing it in the live session. Get the same denominator and just compare the numerators. So have a go. See about these ones. You are probably going to have to use your times table knowledge to help you. Have a go, see what you can do. Okay, so the first one, 12 can be put in terms of 24. It's timesing it by 2. So we times 12 by 2 to get 24, times 16 by 2 to get 32. We can then compare the two denominators, and 32 is bigger. Relationship between 21 and 7, times by 3, isn't it? So we can times this one by 3, and we have to times the top by 3. And then we have 30 21s. 30 21st, 26, 30 is larger again. And then down here, how do we get from 4 to 44? What do we do? Yes, we times by 11. That means we times the top by 11 as well to get 66. Then we compare 66 to 89, and 89 is very definitely bigger. Hopefully that stage of this is okay, because all we're doing is following exactly the same rules we did for numbers fractions under 1. We're just using our equivalent fractions to get the same denominator and then comparing the numerators. It's identical. We're also just using our knowledge of improper fractions. Okay? So, there is another way of knowing this. And the way of knowing this without having to do the equivalent fraction is 89 divided by 44 is larger than 2. We can fit two 44s into 89, but we can't fit two 4s into 6. So that implies that this must be larger. Just another easy way to do it, but I understand that might confuse people. So if you don't see that, and it's a matter of seeing it, then you can always use getting the equivalent fraction to get your same denominator to compare them. Okay. This is an interesting one, and this is one we've talked about before. What do we have the same? Well, we can draw them out if we wanted to, and that would give us an answer. And that's fine. It's just complicated when we've got large denominators. Or we can use our rule. When the numerators are the same, in this case both 15, then we can compare the denominators. And remember, this works in the opposite way. So the smaller the denominator, the bigger the fraction. That's the way to remember it. The smaller the denominator, the bigger the fraction. 10 is smaller than 13, so this is the bigger fraction. And you can see that here. This piece, look at the size of this one piece here. Whereas look at the one size of this piece here. It is bigger. So we'd want these pieces if we have the opportunity, the same number of these pieces rather than these pieces, because we just have more. Not a huge amount more, but we have more. Okay, everything's okay. So we've got to compare 27 24ths and 9 fifths. So you're lucky here it's kind of told you what rule to use. But have a go. Think about making the denominators the same and using our equivalent fractions. Try it, and then we'll go through it. Okay, so the way we would work this out is that 5 doesn't fit easily into 24. So straight away, we know that we could use it and work it out, because we could do 24 times 5 and 5 times 24. It's just long-winded. Or we can see that 9 does go into 27, and it's timesing it by 3. So if we were to do that, times this one by 3 to get to 27, we also have to times the 5 by 3, which is 15. Now we can compare the denominators because the numerators are the same, both 27, 24 and 25. Remember, it's the opposite way round. So the smaller the denominator, the larger the fraction. So in this case, we're looking at being 9/5, being larger. Like that. How about this one? You have a think. See what you can do. Can you see any tricks? Which one are we going to compare? Okay, so does 5 go into 7 nicely? No. Does 4 go into 8 nicely? Yes, it does. It's times by 2. So 4 times 2 is 8, and 5 times 2 is 10. We've got the same on the top, 8 to 8s. Just show you that because it's sometimes a bit confusing when it goes underneath. We've got the same number on the top. So now we compare the denominators, and the one that's biggest is going to be the smallest one. Yes, you're right. So the smallest one is going to be the largest because it's got the bigger pieces. Right. What you can also say is that 8/7 is larger than 1 because 8 is bigger than 7. Whereas this side, 4 is smaller than 5, so this is less than 1. That would also give you an idea of what you could look at. Have a look at this one. Rosie and Amir have both baked some cakes. They got a little hungry and ate part of a cake. Rosie says, I have 2 3/4 of cakes left. And Amir says, I have 2 6/7 left. Who has the most cake left? Have a think about it and then we'll talk it through. Okay, so let's have a look. What we're comparing is 2 3/4 and 2 6/7. Which of these two are larger? Well, the first thing we can do is think about this in terms of mixed numbers. We could exchange it into improper fractions and work from there. Or we can do lots of other things too. First off, both of these two have 2 in them. So both of these two are the same. So we can kind of almost just ignore them for the moment. Doesn't matter. That's worth 2, that's worth 2. They're the same. That leaves just the fraction, which is different. And then we just have to compare our fractions. At which point we can see 4 doesn't easily fit into 7, but 3 does fit into 6. So I can times this by 2 to get 6, which means I have to times the bottom by 2 as well to get 8. So our fraction we're going to compare is 6/8 and 6/7. Which one's bigger? The smaller one. So this one here is the larger one. And there we go. So Amir has the most cake left. So what we can also say is that what we know, what's the same about each of these fractions? Well, we know that 1/4 is greater than 1/7. But because one of these pieces is bigger, which is here, yeah? This piece is bigger than one of these pieces. But the thing is, and this is what we struggled with understanding, is if I have more of these pieces, 6/7, it's hard to judge whether this is more than 3/4 unless we draw it out, or we think about making the fraction the same, which is what we did before. So what I want you to do is think about what we've learned today. Think about the rules that we had during the live session. Use our equivalent fractions, do the same to the top as we do to the bottom. Either find the same denominator and compare the numerators, or find the same numerator and compare the denominators. If we're comparing numerators, then the bigger it is. if we're comparing denominators, the bigger, the smaller it is. So it's in the wrong order. Have a go, see what you can do. Pause now. Okay, let's go through the answers. So first off, the answers for 1 and 2. First one is drawn for you, so it's just a matter of working out which one's larger, which is 3/5. Second one, you have them drawn out, you just fill them in and you'll find out that actually they're the same. And then the same as the next one, fill them in and work out that 13/9 is larger. Then it's asking you to compare the fractions, and this is where we come to our thinking about finding the equivalent fractions. So the first thing is that 4 does go into 8, it's timesing by 2, so that would make that 14 if I times it by 2, 14/8. Then that means that's larger. 4 goes into 12, and it's timesing by 3. So I must times the top by 3, which is 21. That means 21 versus 22. 22 is larger. 12 and 6 can be changed into 12s by timesing by 2. So I times both of these sides by 2. 20 over 12. 22 is larger. Go up here, 10/6 and 5/3. Well, the 3 to get to the 6 is timesing by 2. So we times both parts by 2 and we get 10/6. And you can see straight away that's the same. Again, same here. That 2 is going to a 6, so we're timesing by 3 in this case. We times the 5 by 3 and we get 15. So 15 is larger than 10. In this case here, we're looking at making a 2 fit into 8. I need to times that, both parts, by whatever I need to get from 2 to 8, which is timesing by 4. So it's 20 over 8. 20 over 8 is larger than 18. So this side is larger. And you can see it's just a matter of seeing which number fits into which one in order to find out. So 8 fits into 16, so it's timesing by 2. 2 lots of 32, 2 lots of 18, sorry, are 36. And 36 is larger than 32. 4 goes into 8 twice, means I've got to times 9 by 2 as well, which gives us 18, which means they're the same. And then we've got the last one here, 2 into 4's timesing by 2. This is trying to trick you, but it's not going to work, is it? Because we know that we've got to times this one by 2, because 2 to 4 is timesing by 2. And then we times 18 by 2, which is 36, which means this one is massively bigger than this one. Then we've got 3 and 4. So Philip has 3 and 3/16 bottles of juice, and Scott has 3 and 1/4 bottle of juice. Who has more juice? It says Scott. So 3 and 3/16, comparing it to 3 and 1/4. Now, the first thing we can do is forget about the 3 because they're the same. Okay, then we've got 3/16 and 3/4. 1/4, sorry. So 4 does go into 16. It's timesing by 4. So that's 16 times the top by 4 as well. It's 4, and that means that the 4 is bigger than the 3. So Scott, the second one, has more juice. Then our last question. Rosie's ribbon is 7/4 of a meter long, and Teddy's ribbon is 7/8 of a quarter long. Our ribbons are the same length. Explain why Rosie is wrong. And the trick is, look what is the same. The denominators are the same. So because the denominators are the same, we're looking at the size of the pieces, and quarters is very definitely bigger than 8s. The other thing is 7/4 here is bigger than 1, whereas 7/8 hasn't yet reached 1. So there's multiple ways that you could answer this question. Either you can talk about the fact that the numerators are the same, so we can compare denominators, and these pieces are much bigger than 8s. Or you can talk about the fact that 7/4 is larger than 1, whereas 7/8 is smaller than 1. And that very simply tells us once again that there is a difference there. I hope that makes sense, and I hope that at least going through it again, even though we're using larger fractions and improper fractions, that it kind of helps cement what we've been doing before. I know it is hard, but you just need to keep practicing it and using those skills, and hopefully then that should help. Thank you very much for listening, and I'll see you in the next video. Goodbye.